Welcome to qnawire.
Okay, in this problem we have air at 20 degrees Celsius with a mass we assume to be about 29 times the mass of a proton, U. And we have a spherical vacuum that this air is rushing into to fill it. And we are trying to estimate the amount of time it takes for the air molecules to fill this space, this gap, this vacuum. And we assume this vacuum is a sphere of 1 centimeter radius. So our starting point is we can assume, on average, the velocity of these air molecules are moving at the root mean square velocity. And so if we want these air molecules to go into this 1 centimeter distance of this vacuum, we could say its a velocity can be expressed as this delta D over delta T, where the delta T is the time it takes for them to rush in, delta D is the distance. Okay. We also know that the root mean square velocity is related to the temperature and mass of the gas by this relationship from kinetic theory, where K is the Boltzmann constant, T is the temperature, and M is the mass of the individual particles. So we can equate these things and solve through. So moving on to another page, we have root 3kt over M is equal to delta D over delta T. Thus, delta T, the time it takes for these particles to rush in, will be equal to delta D over all this stuff. So at this point, we can replace delta D with the 1 centimeter radius of our sphere. So 0.01 meters all over root 3, the Boltzmann constant 1.38 times 10 to the negative 23 joules per Kelvin times 273 Kelvin all over 32, 1.66, 10 to the negative 27 kilograms. Oh, I'm sorry, this is 293. And this is 29. Kilograms. Okay, so just repeating that, Boltzmann constant, 1.38, 10 to the negative 23 joules per Kelvin. Our temperature is 293 Kelvin, going from 20 Celsius to Kelvin. And our mass is assumed to be 29 times the mass of a proton, 1.66, 10 to the negative 27 kilograms. So plugging all this in, we are left with a result of 2 times 10 to the negative 5 seconds. So in other words, it would be very unlikely to see a vacuum within our gas last for a very long time, because we expect the particles to rush in well below a second. So these vacuum pockets are probably going to be pretty unlikely. And that's it.